Friday's lesson was all about graphing the families of exponential functions and talking about, when the asymptotes are going to change and all that good stuff. So that was Friday's lesson. Again, already on Thursday, we're taking a test on just sections 7.1 and 7.2. So hopefully you watched the lesson and you're not falling too far behind. But if you are, you better get working on it tonight. Get caught up so that when we have that test on Thursday, things will go better. Now, as I said, we have this strange new thing to study here, and it's called the natural base. It's also called Euler's number. Because he really did name it after himself when he made it an E. So, first of all, he just wanted to name it after himself, and that's the reason. Because most people go, couldn't he have done something else? I mean, couldn't there be a symbol or something that he used for this? Pi has a symbol, that's nice. But no, it was just E, the natural base E. And it is on our calculator. You kind of have to look for it because it's something that we don't use a whole lot. It's in the blue above division. So if we hit second and then division, E pops up. And if you hit enter, that's Euler's number right there. 2.718281828, etc. Now, more helpful for us, there's another key on here that has E, but it has E to a power. And that's going to be this one over here that says ln. That's just to the left of the 4. If we hit second and ln, then it pops up as E to the, and we can just put a power in there. And that's the one we'll use more because we do need to raise E to a power for a lot of the things that we're going to be doing. So how does somebody just discover a number? Well, this came from the fact that when we have a formula, like our growth formula, for y equals 1 plus 1 over x to the x, this is actually a formula that we'll talk a lot more about tomorrow. It has to do with compounding your interest. Most of us, if we're in a savings account, our interest gets compounded quarterly. So it doesn't happen every year. It happens 4 times a year. That's 4 quarters in a dollar, 4 quarters in a year. And when that happens, they do compound that interest. It's actually a good thing for us because that means that we get more money. Now, that was not how this was made. This was made by Leonard Euler, who really was trying to figure out, how do I become a loan shark? And he figured out, hey, I'm charging people every year right now, and I'm not making a whole lot of money. How about if I charged them every month? So he tried that out for a while, and he's like, no, not enough money. I need to make more money off of these loans. I want to charge people every week. Got greedier. I'm going to charge people interest every day. Still wasn't satisfied. Every minute of every day, I'm going to charge them interest. Still not satisfied. He wanted to charge people interest all the time. So that if somebody came up to him and said, I want to pay off my debt, how much do I owe you? He could say, well, do you want to talk about what you owed me just a minute ago when we talked? Or do you want to know in 5 minutes when we're done with this conversation how much money you're going to owe me? That's what he wanted. He wanted to make more and more money. So he was a loan shark. So as he continued to make the x in this equation bigger and bigger and bigger to say, I want to compound this thousands of times every day, unfortunately, he noticed something, and we're going to see that. It's called the natural base in a lot of books because it is used with logarithms, which we aren't going to get to just yet. So natural base exponential functions use the base e, and they have the same properties as other exponential functions. We use e like a variable until we need to know how much it is. So this one says, how could we use the graphing calculator to evaluate e to the third? And it shows us on the screen exactly what I was showing you a little bit ago. That if we hit second ln, e to the power pops up. And then you can just put in the third power, which is what they wanted, and enter. And there it is. Now usually with e, we go 4 decimal places. I don't think your book does that, but because it has to do with logarithms, and logarithms historically have gone 4 decimal places, usually they're written to 4 decimal places. So we can see it right here. Now, they did it a different way for this one. This one was just, hey, let's punch it in, e to the. For this one, they said, well, let's go ahead and graph it. Let's see what e to the something looks like when we graph it. So let's go into y equals, and let's do that. Let's do second ln, and let's put e to the x. And we'll do zoom 6 and take a peek. And I hope we notice that looks exactly like our growth functions that we were graphing last week. Why does that look exactly like our growth functions? Because e is 2.7183. I'll put it like the calculator there. Ugh, I hate doing that. Let me get that off of there, and if my eraser will work. So then you think, well, that makes sense because our base is bigger than 1. And whenever our base is bigger than 1, it's supposed to be growth. So e is just another number. It's 2.718, blah, blah, blah. And over here, they said, if you didn't care how many decimals you're going, you could even just use the table feature to find e to the third. So depending on what they ask us to round to, we would want to just go ahead and punch it in and see what we have. So this one says, how could we use a graphing calculator to evaluate e to the 8th? Well, let's punch it in. Back to the main screen, second ln, we just put an 8 in there. So 2,980.9580 to 4 decimal places. Your book only goes 2 decimal places, so we'll go 2980.96. So in your homework, there are literally going to be some problems that just say find e to the 7th, find e to the 4th, find e to the 9th, because they just want to know, can you find those buttons and use them? Anybody that can't find the buttons? All right. Now, like I told you, Leonard Euler was being a loan shark. And so what he did, we'll come back to that problem in a second, is try to figure out if I could compound interest all the time. And that's called compounded continuously. Now, these are 2 really important words, because part of this test is going to be several interest problems that are going to look like word problems, and we have to know which formula gets used for what. To use Euler's formula, we have to see the words compounded continuously. Now, they might reverse them and say continuously compounded. It means the same thing. So what happened as Euler kept increasing the number of times that he was going to charge people interest every day is at some point he noticed, hey, this number doesn't get any bigger. And that's because money only goes to how many decimal places? 2. And the changes that he was seeing when he was trying to charge people interest 100,000 times a day were beyond 2 decimal places. But he did give us a new formula for continuously compounded interest. And that's what this one is. So continuously compounded interest. And that green, again, is really hard to see. So A of t equals P times E to the RT power. So P is the principal. How much did you put in? E is a number on the calculator. R is the interest rate as a decimal. We'll just move it 2 places. And T is, how many years are we talking about, you know? Now, I have never had a problem remembering this formula. Here's why. I grew up in the 80s, and my mom was so thrilled. This commercial came on one day, because there were 4 of us gals in the house. And it said, Save money. Shampoo and conditioner all in one. And this was the shampoo. Now here's the problem. It stinks. It smells like chemicals. So us girls were like, and I can't even, in a normal year, I let everybody pass it around because some people want to say, no, that doesn't stink. Usually guys, because some of you use some pretty strong soap, and so you smell the chemical stuff like this, but I can't pass it around this year. But notice the name, PERT, P-E-R-T. That's how I remember this formula, the stinky green shampoo. And that's the continuously compounded formula from Leonard Euler trying to charge people interest all the time. So now let's back up down here. How long would it take to double your principal in an account that pays 4.5% annual interest compounded continuously? So as soon as I see this, I think stinky green shampoo. P times E to the RT. And then I think, well, how much was I supposed to put in there? It doesn't say. How long would it take to double your principal in an account that pays 4.5% annual interest compounded continuously? Well, that's because it doesn't matter. So we can just pick a number that would be really nice to work with. I'm going to pick $100. I'm going to put $100 into this account. If I double that $100, how much would I have? $200. See, some easy math, like that part. And then E to the, and it said 4.5% interest. What's that as a decimal? And we don't know what T is. Again, this requires to solve it by hand, logarithms. But we don't know logarithms yet. So what we're going to do is put this in as y sub 1 and this in as y sub 2, and we're going to see how many years is it going to take for that to happen. So I better get this to where I can see it here. Maybe if I just move it down a little bit, I can still see it while I put in my calculator. Y equals 100. Second ln gives me that e to the, and it was 0.045. We're just going to use x. That's the normal variable for us. And enter, bless you. And I want to know when that's 200. So now again is when we have to think about the problem and try to set the window. So we're starting with $100. We want it eventually to be 200. I'm thinking that might take a little while, so maybe 0 years to 30 years. And I know I have to be able to see 200 for my y's, so I'll do 0 to like 250, 300, something like that. I just have to be able to see it. So now what I'm going to see first is that growth curve for my A equals P times E to the RT. And the second line I'm going to see is going to be my 200. So graph, aha, we can see where they hit each other. So let's wake up Blinky. Second trace, number 5, bing, bang, boom. Almost 15 and a half years. Let's put 15.4 years. Now again, if you remember what I said the other day, the bank isn't actually going to give us that money until 16 years because our contracts always say you have to wait till the end of the year. But for the purposes of the test in the class, we're just going to say 15.4 years is how long that would take. So whenever we read continuously compounded or compounded continuously, stinky green shampoo formula. All right, this one says continuously compounded interest. Scholarships. Suppose you won a contest at the start of the 5th grade that deposited $3,000 in an account that pays 5% annual interest, compounded continuously. How much will you have in the account when you enter high school 4 years later? Express your answer to the nearest dollar. We're not going to do that. Put a line through this. If it's our money, we want dollars and cents. We're not going to round to the nearest dollar. Dollars and cents. All right, I saw my 2 words that I needed. The CC, compounded continuously. Stinky green shampoo formula. There it is. Well, let's see. How much did they put in? 3,000. And there's our E. Interest rate is a decimal. And how many years are we leaving this money in? So what we're really trying to find here is A of T, the amount after T years, when T was 4. So we could punch this in exactly as it is, but some people get messed up with the exponent having multiplication in there. Don't worry about it. The calculator takes care of it anyway. But if it drives you bonkers, just think, I've got 4 nickels. So if I have 4 nickels, how much do I have? 20 cents. Oops. There it is. But like I said, the calculator will take it and it'll do all the math for you. So back to the calculator. Back to the main window, 3,000. Second ln for our E. And then 0.05 times 4. Notice I just punched it in. Didn't have to figure out that it was 20 cents. $3,664.21 is how much money we would have. Now, who can get continuously compounded interest? People that have lots and lots of money. You and I generally can't go into a bank and say, I'd like to put in $250,000 into an account and negotiate what we're going to get for interest. They're going to say, no, that's not how we do it here. You know, everybody gets quarterly interest. But if someone were to come in saying, I have about $5 million that I would really like to put in your bank. But you see, I have offers from other banks to put that money in. So could we negotiate here for continuously compounded interest? Then maybe they'll do it. Now, why do banks want to do that? I mean, they're going to have to pay somebody to have that money continuously compounded because they make more money off of what they loan to other people. The current lending rate is for every dollar a bank has, whether or not it's in the cashier's till or it's in the vault, they can lend out $3 to somebody else. So they're still going to make money by doing that. That's the reason that they'll negotiate with somebody that has a lot of money to give them. Should never do that, by the way. Each of the banks is only insured up to $100,000 by the FDIC. So if you have a lot of money, you should be spreading it around to a lot of different investments and places. Because if the bank goes belly up, you lose your money. It's all gone because it's only insured to $100,000. Well, okay, almost all of it would be gone. You'd still have $100,000. Most of us would say that's pretty good. All right, about how much will be in the account after another 4 years of high school? Oh, so you decided to leave it in. So there's the 3,000. Still at 5% interest, but now instead of leaving it in 4 years, we're leaving it in 8 years. Well, let's see. And I'm going to cheat. I'm just going to call up the last thing I typed in. So second negative. Oh, it's not going to let me. It won't do it with E. I thought it would let me just change the exponent. It says no. Type it all in again. Second ln 0.05 times 8. 4475.47. So $4,475.47. There it is. So if you leave it, you make a considerable amount of money just leaving that in there. Now, example 5.5 says, how long would it take to double your principal in an account? Oh, we did this one already. Was it in this spot in your packet? It wasn't on the back one? Oh, I'll have to delete that out of there. We decided to move it around. So, question then. Does it matter if I use $100 and $200 or $5 and $10? It doesn't matter as long as I can change my window so I can see it. That's all that matters. So the key features from today were, on your calculator, find me what E equals. So E is about 2.718 or so. And it's kind of like if I ask you what pi is, do almost all of you say 3.14? Anybody go farther than that? Sometimes there's people, that memorize it a little bit farther. So E is just a number. That's all it is. It feels weird because it's a letter, but it's actually a number. And that's where I want to stop for today because I just wanted to get through the formulas that use E, and then tomorrow we'll talk about compound interest formulas. So this means you have to go back in your pile of stuff because one of the things we're going to be working on the next 2 days, it's called the compound interest worksheet. It says compound interest assignment up there at the top. We're not going to do it all at one time. We're going to do pieces as part of our homework. So what I will do here is I think I have both pages. If you can't find it, after you write the assignment down, I'll put it back up here so you can do those. So there's day 2's assignment. And then, like I said, after I see everybody has it written down. So a few of them from the book. This is where it says find e to the 9th, and that kind of stuff. A few book problems. And this will work out well if you don't have the worksheet anyway, because what you can do is you could just do it on this sheet of paper that you have for 16, 17, 20, 21, 26 to 30. So when you submit this assignment, don't forget you're going to have a couple of photos here because you have to have the book part, and then you also have to have 9 through 15 from the worksheet. You might want to go ahead and do the worksheet ones first because those are probably going to be pretty fresh in your mind since we just did them.